The search is on for the oldest ice on Earth. Later this month, European scientists plan to drill 1.8 miles into Antarctic ice sheets in an attempt to uncover ice that is more than 1.5 million years old. Their project aims to answer questions on big shifts in the Earth's climate throughout its history. The researchers' project, named Beyond EPICA, Oldest Ice, will investigate a new site on the desolate white continent. The project intends to extract tiny air bubbles from deep beneath the ice's surface. These bubbles will reveal the levels of heat-trapping gases such as carbon dioxide that were once in our atmosphere. The chemistry of this ice can also be revealed past temperatures on our planet. Once the scientists have found a good site to drill, they will also embark on a study spanning several years in which they extract a 1.8 miles deep core of ice to the surface. Laboratories across Europe will then study the ice to unveil how our climate and atmosphere have interacted over the past 1.5 million years. We've got a very good record of what's been happening over the last 800,000 years, but there are some aspects which we cannot fully explain, Dr. Robert Mulvaney from the British Antarctic Survey told the BBC. By studying ice that's 1.5 million years old, it should give us the underpinning belief that we really do so deeply understand the climate system that we can be absolutely sure that what we're projecting for the next few hundred years is based on a complete knowledge of the science. The researchers' site is located 30 miles away from the nearest human settlement. The French-Italian station Concordia. Concordia is based at the current oldest ice core site ever found, known as Dome C, one of the most hostile environments on the planet. Average temperatures often dip below -54 degrees Celsius, and blizzards whip through the camp on a regular basis. The researchers will study a new nearby site labeled Little Dome C. Supported by those at Concordia Station, they will travel hundreds of miles by tractor and ski-doo over featureless snow. In the early 2000s, we drilled an ice core from Antarctica that gave us a climate record going back 800,000 years, explains Dr. Mulvaney said. Now we want to double the length of that record to investigate an important shift in Earth's climate around 1 million years ago, when the planet's climate cycle between cold glacial conditions and warmer interludes changed from being dominated by a 41,000-year pattern to a 100,000-year cycle. Understanding what triggered this shift in Earth's ancient glacial cycles is key to our understanding of climate change. If rising atmospheric carbon dioxide levels, alongside a slight tilt in the Earth's rotation, caused the shifts over 1 million years ago, then the secrets packed under the Antarctic ice could help the scientists understand better how ice sheets will behave as the world warms in future. We need to understand the interaction between the Earth's atmosphere and climate in very different conditions in the past if we are to be sure we can predict the future climate response to increasing greenhouse gases. Dr. Mulvaney says, there is no other place on Earth that retains such a long record of the past atmosphere other than the Antarctic ice sheet. It is tremendously exciting to be embarking now on the journey to recover this record. The team will investigate several sites dotted around Little Dome C using a radar towed behind a specially modified tractor. They will drill test boreholes to inspect each site for suitability and to analyze the brittle bedrock that lies under Antarctica's thick ice sheets. The researchers will inspect the thickness of the ice sheet, its physical properties, and the topography of the bedrock below at two different sites, Little Dome C and on the East Antarctic Plateau at Dome F. They say that how thick a sheet of ice gets is just a first indicator of past ice, as different snow accumulation, ice flow behavior, and the temperature at the bottom of the sheet also determine whether old ice remains. During previous studies, we determined key regions where we expect the oldest continuous ice record on Earth, says Professor Olaf Eisen, project coordinator and glaciologist at the Alfred Wegener Institute. Now we have to prove this, and it is important that we learn as much as possible about deposition processes and the composition of the ice, he explains.